Good morning. I'm Dennis Preshak, President and CEO of the Plastek Group. Today I have the extreme pleasure of introducing our guest speakers for today's webinar. They are Mitch Hecht, Founder and Chairman, and Chris Dow, Chief Executive Officer of International Recycling Group. International Recycling Group, or IRG, is a startup company based in Erie, Pennsylvania that is planning to build what will be the largest plastics recycling plant in the world. As they will soon explain, in addition to its sheer size, another unique aspect of IRG is that it will be a 100% non-landfill solution to plastics waste. So without further delay, here are Mitch Hecht and Chris Dow to tell you about their company. Gentlemen.
Good morning. Good morning. Thank you, Dennis, and thanks to your company, the Plastek Group, for your enormous support. So we're not going to be, unfortunately, joined by Chris Dow this morning, but instead we have our Chief Engineer, Lee Clayton, joining us today in his stead. And Lee has designed this plant, so he's familiar with it. So let's get started. So why a hyperscale regional sorting facility, the largest of its kind? So recycling rates today for plastics, we all know, are extremely low, 5 to 9%, depending upon whether you're looking at DOE figures or EPA figures. And the reason that is because we don't really have a problem so much with technology on recycling plastic per se. It's that we have a breakdown in the collection system. And the reason for that is that the traditional haulers that we use to collect our recyclables are really only collecting the ones and twos, what we call the ones and twos programs, PET, high density polyethylene, just the containers. And unfortunately, this is less than 1/3 of the waste plastic material we generate in our households. And by doing that, we're really just limiting the amount of material we collect. And the reason they can't collect more is that there really is no market for anything else. There's some market for polypropylene that's developing, but for the vast majority of material, if Waste Management, Republic, or other traditional haulers would ask communities and households not to sort their plastic, but to give them everything that they have in terms of post-use plastic, the vast majority of that material today would have no mechanical recycling application and would have to be landfilled at a very high cost. So by limiting the spectrum of materials that are coming out of a household and that haulers are willing to collect in any recycling program, it's really doing a disservice and counterproductive to large-scale plastic recycling. Where we need to get to is to move to all plastics programs to remove the frustration from households, homeowners, from trying to sort between, figure out what's good plastic and bad plastic, what goes into the recycle bin, what goes in the trash, just to give us all of their plastic, to dramatically increase the amount of material that is recovered, and then hand that over to a large-scale, industrial-scale sorting facility and processing facility where at very high speed, incredibly low cost with pinpoint accuracy, we can then separate out those resins that can go back into recycling and be turned back into new products. And we know the PET is extremely recyclable. Those bottles can go back into other bottles. High density polyethylene, what we call the number twos, the milk jugs and gallon jugs, can be returned back into jugs. And now polypropylene, some of these containers can go back and be reused. And of course, the Plastek Group would be a large user of post-consumer polypropylene. So the concept was to build a large-scale plant. Now, you couldn't do that unless you had a non-landfill home for absolutely everything. So the concept was, I came out of the steel industry, and in what we found was in Japan and in Germany and Austria and the EU, the steel industry was being asked to consume material that wouldn't otherwise be able to be recycled and would go to landfill and consume that material by diverting it from landfill in the blast furnace of the steel mills. And what they found, the scientists knew, was that in the blast furnace of the steel mill, plastics and combusting that plastic does not create carcinogenic emissions, dioxins and furans, we normally associate with consuming plastic, combusting plastic, cannot exist because of the extremely high temperature and low oxygen environment. And in fact, you get an environmental pickup because in that case, you're using this plastic that would otherwise go to landfill to replace coal. And coal, as we know, is the dirtiest of fossil fuels. And because plastic is a hydrocarbon, you're actually getting a reduction in CO2 emissions, and there are no additional emissions from using the plastic to substitute the coal. So what I've done over the past 5 years or so has been to work with the US steel industry to transfer this technology developed in Europe and Japan to the US. And we received support from Erie Insurance and the Plastek Group to develop that project in Erie, PA, which happens to be a terrific location because the feedstock or the post-use plastic that is coming from the Northeast Midwest is going down to the Southeast where it's processed there and then has to come back for plastics manufacturers in the Northeast. So that has been our concept. Once we build a plant where we can consume all of the material, where we have a home, a non-landfill home for everything, then we can really move to dramatically move the needle on collecting more plastic from homes. People aren't frustrated about rules of what's good and what's bad, and that encourages more people to feel truly like get beyond the cynicism that most plastic is being landfilled, which it is today, admittedly, and now we can actually have kind of a revolutionary development in plastic. So let's go to the first slide. So we found a wonderful location here in Erie. This is a former hammer mill paper site that was years ago. It's clean environmentally. That particular site was not really used for manufacturing; it's more of a storage facility. So it's an opportunity zone. So it's federally incented, but where there's a significant amount of jobs that are needed on the east side of Erie, and we can create hundreds of manufacturing, clean tech manufacturing jobs for the future. The plant is going to be 195, 200 million investment at the end of the day. And again, we're targeting a region with a large feedstock supply and a sizable downstream plastics industry that is really hungry for post-consumer plastic to add in as a portion of their plastic manufacturing. And this is really a trend. Every consumer products group needs their plastic packagers to start increasing the amount of recycled content in their packaging to reduce the amount of virgin plastic material that's being made by the oil and gas industry from petroleum products. The site happens to be ideally located. We have a rail spur, and we're right at the intersection between I-79 and I-90. So there's great transportation to all regions of the country. Let's go to the next slide, please. Our products are going to be fully, for today, the mechanical recycling products are, PET, number 1, high-density polyethylene, number 2, and polypropylene, number 3. Our goal is not to eliminate whatever waste fraction is ultimately going to the steel industry. The steel industry, which would be a modest proportion of material going to steel today. Ultimately, the goal is to phase that material out as we develop more and more applications, recycling applications for more materials. We're stuck in this chicken and egg where we don't have a lot of recycling applications for many resins because nobody is collecting it. The haulers just aren't collecting their curbside programs. And the curbside programs aren't collecting it because there's no application. So to get past this chicken and egg, we have to create this bridge of a very large-scale campus to drive all resins coming through. And to the extent that somebody develops recycling application for low-density polyethylene, for example, which would be terrific. Somebody wants 10,000 tons of LDPE. We will pull that away from the steel industry and have that go into recycling application. So our goal is to maximize the closed loop and to try to recycle everything we possibly can into finished products. Roughly the numbers are total throughput of 150 to 200,000 tons, with about 25,000 tons a year of PET clear material, natural HDPE material, pigmented HDPE material, and then in mixed color polypropylene, all of which, well, the vast majority of which will be pelletized, and we will talk about our products going back to recyclers and having those recyclers turn those back into finished products from recycled materials. So with that, let me now turn it over to Lee, and he can walk through the other slides, and then we'll have Q&A at the end of the presentation.
Okay, thanks, Mitch. My name is Lee Clayton. I spend 50% of my time in the UK, and the rest of the time I spend in the US. I've spent 30 years in the plastics recycling sector, and my colleague who you'll talk to later, Stuart Kershaw, both he and I have worked together on some of the largest packaging reprocessing plants both in UK and Europe, and we're now working with Mitch to sort of bring some of that knowledge that we've gained over the years with this project in Erie. And so if you can go on to the first slide, please. As Mitchell has already intimated, that the target materials aren't going to be as specific historically. So we realized in Europe that if you were being very specific with your materials, either HDPE or PET, you were losing out on other materials that otherwise could have been lost, burnt, buried, or landfilled. And so the plant has been designed to be very versatile in terms of the materials that it can accept. So we can accept segregated feedstocks, both HDPE, PET, polypropylene, etc. But also we've developed what I would term as a swing plant. And if you go on to the next slide, please. We'll also be looking to accept upwards of 90,000 tons of the harder to recycle materials that contain sort of non-target materials in there, be it PVC, polystyrene, LDPE, as Mitch has already said. And the plant has been designed to extract those non-target products, and I'll say products are not waste, and we'll deal with them in an appropriate manner where they can be baled, shredded, and used in the steel industry, as Mitch has already alluded to, rather than have them exported, which has now become unattractive, and likewise landfilled. So the plant and the process, as we've taken many months to design it with some key suppliers that we've worked with in the past, and have got a great knowledge in terms of this. The technology's advancing year on year to enable us to target those polymers, colors, shapes, and some of the additives that are within those products to remove them, deal with them, bale them, and segregate them, so then we can look for a more appropriate home with them going forward. If you can go on to the next slide, it'll be a little bit easier. So this is the important part. So that the front end of the plant, this is the initial draft of the sorting, and you can see that we've got various injection points for various materials, and we can alternate between those depending on what material we're looking to segregate and source at any one time. So if the mixed material becomes the orphan to the segregated, the plant can automatically adapt and accommodate those different shifts in volume. So when we get to the washing plant side of it, we've designed and instigated some unique areas within the plant that will enable us to decontaminate the mixed material against the segregated materials to remove some of those barrier-laid materials, trays, which have become a huge problem in Europe. We'll remove those and bale those separately and start to do some business development on the tray material, which is predominantly PET, but has its own challenges. And then the other materials that Mitch also mentioned, the styrenes, the LDPEs or non-targets, will then be baled and shredded separately and then used as an alternative to coke within the steel industry. Once we've been through the intensive sorting, the materials are then sent in a segregated form to 4 different wash plants. We've got intensive rinsing, granulation, size reduction, air classification, further NIR detection at the end of the plant to make sure that that material is polished sufficiently to then be introduced to the extrusion, decontamination through the extrusion process that then will allow us to produce material that will be suitable for a letter of non-objection status going into the food industry. And again, the plant has been designed where we can swing between coloured, non-coloured, depending on what the customer or client requests. And so the overall plant, as Mitch has mentioned, will have a process input capacity of between 150 and 200,000 tonnes per year, and it will give us approximately 100,000 tonnes across target materials of pelletized and flaked, depending on what application we're going into. And so we feel very confident that this design and this technology will enable us to meet the needs of the blue chip blow molding extrusion companies, that will give them confidence that the material that we produce today will be the same material that we produced within 6 months' time. That, you know, continuity is key within manufacturing, and that it's easily adapted to your existing feedstocks. So we're very confident that this process, as Mitch said, it's certainly going to be one of the largest in North America. It will give us an advantage in terms of operation scale and allow us to accept material that other people would otherwise not want to recycle because it's either challenging, the yields are uncomfortable, and we will utilize all that material into a product, be it a low value or a high value application. And I think that's probably the end of my overview, and we can take it to questions if you like, Mitch, unless there's anything you want to add.
No, I think that's good. I'm sure we'll have a lot of questions and we can get into some of the details. But again, just to go back to our first principle, the concept here is to dramatically increase and provide a home for the curbside collectors today to collect more material, to move and shift to all plastics programs, to get the communities, get residents engaged in feeling confident that if they put more plastic material in the recycling bin, that recycle bin will be cared for and handed off to a large-scale regional low-cost plant to dramatically change, increase recovery of all recycled materials that will then go back into as high-value products as we can get them. So I guess we can go to the next slide, and Nicole, maybe we can open it up to Q&A. And I guess what I'd like to do is also bring in Stuart Kershaw, who is another member of our team. And Stuart is in charge of our product sales, and he's right now negotiating with several potential off-takers of the material to determine exactly what the product mix will look like and where are the best applications for the material coming out of our plant. So Nicole, do we want to open it up to questions?
Yes, thank you, everyone. I am joining you here as the moderator for the Plastek Academy in this presentation today. As Mitch said, we have Stuart on as an additional guest speaker, so we're very happy to have the team here to help us understand and get excited about this long-term vision and everything that everybody's been waiting for on the sustainability side of things. So hopefully well, that we have everybody's support and we have a great audience here today. So before we get into the logistics of submitting your questions and actually answering them, while you are, as our audience members are thinking of those questions, we also want to have Stuart take the floor and comment on his role in the organization and what type of questions additionally that he can answer for you today.
Thanks, Nicole. Hi, so I'm Stuart Kershaw. I'm a plastics recycling specialist based in the UK, but traveling to the US periodically. And I'm the VP for sales of the finished products from the IRG business. And as Mitch and Lee have already alluded to, we're looking at around 100,000 tons of output, split between PET, HDPE, and polypropylene. So we have we've created some draft specifications for those products. So we have a fair idea of where we're going to be in terms of finished product qualities and the properties of those materials, and which products will have letter of non-object food contact status and which ones won't. And as Mitch already said, I'm working on various outlets for the products. Some are very much traditional, as I'm sure the audience are aware. A lot of this material has established roots, and others not so well established. So it's all about finding the highest value for those products, which in turn levers the economic viability of the business. If you don't get high values for the products, then you don't have a successful commercial operation.
I should say I think I left out some important aspects which folks might be interested in, as the timing. So we're prepping the site. We have the site now. We're hoping to break ground on the site preparation facility at the beginning of next year, and we're looking to sort of end of 2024. Worst case, we have supply issues with equipment, beginning of 2025 for commissioning of the plant and having material ready to go.
Wonderful, very exciting. We can see the future ahead. So I do have some questions coming in, so I want to take a moment, gentlemen, to let you gather your thoughts and prepare to answer some live questions from our audience today. We have a couple of different topics, so I want to thank Jay, Frida, John, Lynn, and John for starting us off. First question coming in. This is very exciting. Thank you. Are your plastics 1 through 7 mechanically processed, or is there chemical recycling involved too?
I'll kick that off to Lee. There's no chemical recycling going on, and this is all being sorted, and the process that we use is mechanical recycling. But I'll leave to the expert. I'll leave to Lee to answer in more detail.
No, we're mechanically recycling the polymers through high temperature, high attrition, through mechanical recycling, and then the polymers will be extruded through known high technical extrusion processes, which will then decontaminate the polymers from any migrated volatiles or additives that are within the polymer to meet the necessary challenge tests that are required for an LNO. So no chemical recycling within this process at all.
We're sort of I think the jury is still out on chemical recycling. Quite honestly, we've looked at it as the potential for some of the applications, some of the material that we cannot do mechanically. And of course, when we talk about mechanical recycling, as Lee mentioned, for a layman like myself, it's near-infrared machines, light rays used to identify the footprint in a resin, to identify that resin, and then puffs of air that will separate those pieces of material into the various buckets of PET, HDPE, and polypropylene. And those 3 resins can be easily mechanically recycled, and then we go into the shredding and washing. But there are no reactors. We don't believe in all that. We think it's high cost. We think it has a potentially questionable carbon footprint relative to manufacturing pure resins. So we're keeping it at the mechanical.
Next question I see, how much plastic will IRG collect per year? What percentage of that total could be sourced from Erie? Do you have any forecasts on that information?
Well, we're collecting a massive amount, and so this is truly a regional plant in the sense that our collection radius is 750 miles radius. Essentially, our collection will be potentially half of the population of the United States. Only a small fraction of that material will actually come from Erie. But the real benefit for Erie, besides just the fact that we're going to have this cutting edge, first of its kind, largest in the country facility campus that's really going to take Erie to kind of the next level on environmentalism and leading the way on recycling. The benefit is to the homeowners of Erie, because what this will allow is to finally get away from, in the case of Erie, it's waste management, but it could be the other couple of haulers, of just saying, we only want, your 1s and 2s. We only want a container with a a neck and a screw top, and that's the only thing we'll collect. So where we're going to get to is we're going to collect everything in Erie, and also in Erie we're starting a little new program called Newbin, where we're really going to start piloting, saying let's move away from just collecting limited materials, let's collect all your materials. And again, that's going to take a lot more plastic out of the trash, have a lot more people engaged and involved in wanting to hand all of their plastic over, and also give people a sense of integrity and validity, that you could actually go and see that this material is not going to landfill. So much more of it's actually being recycled, and it's going back into finished products. Again, there's going to be a modest percentage that would be, will go to landfill. We'll go to the steel industry as a last resort rather than go to landfill. But now, while it's looking now, it's 80 to 90% of our materials going to be turned back into products. That's going to be incredibly exciting, not just folks in Erie, but in the entire region. So thanks for the question.
Certainly. So as we kind of piggyback the questions and thought process on availability and different types of materials that will consist and be processed through your vision here, we have a question asking, have adequate sources and end markets been secured or identified? From what I understand, much of these materials are already claimed.
Well, I mean, I can start, and then Lee can pick it up. So we're in discussions now. Feedstock, there's an enormous amount of feedstock and potential feedstock. So today, only a small fraction of the material is actually collected by the MRFs, and they sort that material and they sell it. But it's actually, even though it's a small percentage of the, let's say 35 million tons of waste plastic that comes through the municipal solid waste stream, and 95% of that is going to landfill today. Let's say 5% of it is being collected. Nevertheless, in our region, that's about 850,000 tons based on the latest studies that we've seen. 850,000 tons that actually is being collected and that would be available for sale that we could pick up. And again, as Lee mentioned, we're anywhere from 100 to 150,000 tons that we would need. The advantage that we will have as a purchaser of, let's say, 100 to 150,000 tons out of a supply of, let's say, 850,000 tons that is being collected by haulers, we will have by far the lowest costs in the industry, just by virtue of extremely large scale and the fact that we won't have a yield loss. So any waste that comes in, again, we repurpose that and we can sell that to the steel industry. So that yield loss doesn't go as a $60, $70, $80 per ton tipping fee to landfillers to have them bury that material in the ground. And by the fact that we have extremely advantageous economics in our plant, we feel like we can be the price setter when it comes to acquiring this feedstock. So we're not concerned that there's not enough adequate material, and we're highly confident that we will be the best buyer of that material out there. So I don't know if Lee had anything else you wanted to add within a European context, maybe what you've seen.
The question could be, why is a Brit interested in the US market? I think the potential is exponential. So only just today, the Europeans are now experiencing a shortfall in materials, but what we're seeing in the US is that you're recovering 9% of what you're producing. So it's a drop in the ocean. And both Stuart and I have spoken about this many times, that America's usually about 5-10 years behind what's going on in Europe. Once the US decides to collect and recover, there will be a tsunami of material that needs to be ethically recycled, and as Stuart's already alluded to, it has to be a super clean, high value end product to complete that circular economy that everybody's talking about, sustainability, to show that this material is appropriately dealt with, landfills reduced, zero export. And so the volumes are there. The volumes are there now in what you're collecting, which is a very small amount of what you're actually consuming, what we're consuming. And so that 9% only needs to become 10%, 12%, 13%. And you're going to need more plants like this regionalized around the US just to handle that material. And so we as a team are really confident that A, the material's there and it's available. We'll have best economics of scale, good outlets. The material will be as clean as the material can be, and then more and more material will be collected. We've already experienced in Europe that if you collect more of the mixed, you'll get more of the segregated. It just comes by default. And so, and that's just not plastics, that's cardboard, that's steel, that's aluminum. And so we as a business are here not just to accept the material that's already been collected, but stimulate and educate why we should be collecting more and how we should be recycling it and where it should be placed, and giving the end users confidence that material is. We used to work on the 3 C's. It was compatible, it was consistent, and it's commercially viable. Those are what you've got to meet for your customers. We're confident. We've already done it. We've done it several times, Stuart and I. Some very large plants. This is by far the largest, but we've already done it. We've succeeded in it. We've grown the business, grown the markets. There's huge acquisition in the waste sector. We're very confident that not only can we get the material that's there, but also encourage more material to be collected and recycled.
Very good. A lot of information to gather here, as this is a huge project. It's right there in the title, you know, the huge recovery facility. So a lot of things to consider from all across the board: the who's, the what's, the where's, the when's, and the why's, and the how's. So as we want to share with our audience here, which is global audience, global companies, global experts. So again, thank you all for joining us. We want to bring that value, and as everyone's efforts are to make our world a more valuable place, more sustainable place. So let's talk about value a little bit from the material side of things. We have a couple questions here addressing that. One, for starters, is we're talking about the UK and the US. A late joiner here, just to let you know, we are speaking of this development here in Erie, Pennsylvania in the United States. So with that said, the question comes across: the best way to prevent waste is source reduction. So what is the overall energy use of the collection, transport, all the processes at the plant and transport to plants and other end users? Is this the most appropriate use of dollars and people power versus using less packaging and reusable and returnable recycling?
Okay, Lee, I don't know. I'll pass it off to you. But look, I think it's reuse, reduce. All of those have to come into play. There's no question that we have to use less plastic, and everybody agrees with that. But the problem is we have a crisis today in plastic waste, and we have to address that. And certainly recycling is an essential component of having to reduce the material going into oceans and so forth. So, I completely reject the notion that recycling as a business encourages the use of plastic materials. I mean, the fact is, nobody buys a bottle of Coke because they believe that plastic bottle is recyclable. Otherwise, they would go for other material. So, absolutely incredible reduction in carbon footprint by taking plastics, post-use plastics, instead of having them being buried in the ground or dumped into the ocean. We take that material and we replace virgin plastic with plastic that has already been produced from a petrochemical that was drilled at some point in its past life, and we can return that, replace that virgin material over and over again. So have we done a power analysis from cradle to grave? We do have a life cycle analysis, and of course there are many life cycle analyses that have been performed for mechanical recycling, and the reduction in carbon footprint, the positive impact on climate change, reduction of greenhouse gases is absolutely enormous, because at the end of the day, you're replacing virgin plastic made by the oil and gas industry with material that has already been used, and not taking that material and just chucking it and burying it in the ground and saying, well, let's make some more plastic to replace that material. But I don't know, Lee, your thoughts?
Well, I have a lot. It's a completely different subject that we could talk about.
Sorry, have I disappeared?
Yep, there you are.
I'm
We
back.
can hear you.
My webcam.
Yeah, you can talk for hours
On the pros and cons of using plastic versus other products such as glass, paper, cardboard. And there's a great TED talk actually, which I can send Nicola the link. This lady from I think it's from Lego does a really, really smart TED talk on the benefits of plastics versus other materials. And it's, you know, we can look at, I totally agree that we need to reduce the packaging that we use. It's got out of hand, but we as consumers want food that lasts longer. We've driven that. You should vote with your feet. Don't buy it if you think it's overly packaged. But ultimately, we can't get away from having liquids in a bottle or detergents in a container or certain foods in a container. It gives longevity. It's much cheaper to transport because of the reduced in weight. So there's less gas used when shipping it around. All those facts and figures are there to be seen. We could talk about, you know, pollution in the beaches and in the oceans, and that's quite frankly is a disaster on its own. And we have to work together to encourage those materials to not be sent to unethical recyclers in other countries, which is starting to happen, and have them processed locally. I mean, what are the costs of shipping plastics in a bale to Southeast Asia? It's insane. And I don't want to get onto that subject, but you know, to just ship it a few hundred miles to a process in Erie or somewhere else in the US is far more attractive than the waste management companies baling it, sticking it in a container and shipping it halfway around the world to only yield 20% of it. The rest of it gets dumped in a river, which then gets through an estuary and ditched in the ocean. Plastic isn't going away. Good luck to anybody that goes in a hospital and doesn't want plastics there. You know, we've just been through the worst virus we've ever seen, and they were using, you know, everything was plastic. And so it's here to stay. We just have to reduce the packaging where it's not needed. I completely agree. And we need to recycle it domestically, ethically, and sustainable. That way, these myths and challenges that we're getting over plastics will slowly erode and go away. To just keep mining finite resources to make more plastic is not the solution. The solution is to take those resources, process them, recycle them, and put them back into high value, high technical products. That's all. I've got time on that. But if you Google, there's a TED talk, and this lady gives it, and she goes on about what it costs to make a glass bottle, what it costs to make cardboard containers. It's exponential. So we need to reduce it, recycle it, and make high-end value products that support that recycling.
And anybody that you know, that's attacking and criticizing our efforts in recycling, we're trying to really change and move the needle on recycling. All you're doing is you're speaking from the choir of the oil and gas industry, which wants to make more virgin material, and the landfilling industry that wants to take this material and instead of having it recycled to use their landfills, which of course they make many billions of dollars on, and that's their modus operandi. So yeah, the whole business about bashing and recycling is just kind of a strange curiosity of the last year or so.
Yeah. Mitch, just to add to that, Mitch, there's in Europe and in the States, there over the past 20 years there have been numerous studies on the pure carbon footprint of reprocessing versus landfill, and the studies there are they are numerous, and the cost to mechanically recycle, when you take into account everything from household collection, transportation, sorting, reprocessing, and shipping to manufacturers, is always a factor of several cheaper to mechanically recycle. So I don't think that's ever been in question or is likely to be.
Great conversations that we have going on between you guys. So we are appreciative of everyone engaging, asking your questions on this hot topic, and the team here of experts with their vision, again, striving to get us to the goals of that further sustainability. So with the 5 minutes or so that we have left here on our time frame today for the presentation, I have, I'm gonna bundle 2 questions together from one of our viewers, and then possibly one more follow-up question. So just as a heads up to you guys before our closing comments, moving back to the material side of things, as we've talked about the development of materials, the resources of materials, how they're being sorted, and getting closer to that end product being ready to use by processors and manufacturers. We want to talk about the consistency and quality of it. So our viewer is interested in any feedback you can give on any testing protocols or procedures that you may have in place as you move through the cycle, as well as the acknowledgement of consistency. If we recycle plastic over and over again, there of course will be a loss of physical properties. Do you think that we should recycle with some virgin material to keep the physical properties?
Lee, Stu?
Okay, do you want me to lead on that? So firstly, in terms of testing, the mechanical recycling industry is very well established, is very mature, and the testing protocols on each of the materials are very well established. In terms of equipment, it's again very well established, and the business will have the state-of-the-art laboratory equipment, which has been around for many years. There are additions to that, and they are typically just automated versions of previously developed equipment. So taking PET flake testing as an example, you would typically test oven test some material and then pick out the contaminants visually, and that test is now done automatically using scanning technology, which reduces labor costs in the laboratory and improves the overall efficiency of that process. So that is all particularly well understood, I would say, in the round.
I think if I can just add to that, Stuart, as well. I mean, I was having conversations on this subject today. The technology, so that the equipment, the process equipment that they use at the end of the process now has become so technically advanced that the vendors are almost confident that material is lab ready at the end of it, that they're decontaminating it sufficiently enough. Now, there's no way that you wouldn't put it through your lab, but when Stuart and I were working in these processes 10, 15 years ago, it was around the clock, huge labor intensive testing just to ensure every load was tested before it went out to the customer. But those technologies have just advanced twofold. So not only is the process equipment becoming recognized as part of your testing facility, as Stuart said, it's the labs themselves now, the equipment's become more affordable, more accurate, and therefore give you much more confidence that when you're sending out that load, you give the relevant certificate of conformity declarations on every load that's produced.
And just to add in terms of recycled content percentage and deterioration of product, there is a deterioration when you recycle polymers mechanically. You do get a deterioration. That is an absolute, and we see that every day with recycled content in bottles. The color of them tends to deteriorate. Typically, you get at least six recycle uses out of a PET bottle, which is, so PET being the most widely recycled material or packaging item in the world. You typically get at least six reprocesses before the mechanical properties start to deteriorate too much. But in a country like the US and the recycling rates that you're at in the US, you're a long way off that becoming a problem. It's certainly not in my lifetime or anyone on this panel's lifetime. By the time you've got to 70% recycling rate, that's at the point where it could potentially be problematic after a few years, but we're a long way off that yet. So and what you find is that most packaging manufacturers are using the materials that we will produce at relatively low addition rates, typically 25 to 50%, and they can be used at higher rates, but there isn't enough to go round to get to those higher rates. There isn't enough material supply in the market, and as I say, there won't be for many years to come.
All right, very good, guys. Again, lots of comments, lots of questions, more to come. I want to thank you guys again. We are at the time frame that we've allotted for our webinar presentation today. So as we begin to exit, and thank everybody for joining on behalf of the Plastek Group, the Plastek Academy, IRG, and everyone joining us today. I will allow final comments here in a moment, and want to share one last slide with you on the behalf of Plastek. For those of you that came in late and would like to catch the beginning of the webinar, or if you would like to share this with anyone else in your organization or within the sustainability topic, this webinar recording will be available on demand via the Plastek Group from our website. You'll see that link there on the screen, as well as previous and future webinars within our series. So this is our second annual series with the Plastek Academy, so be sure to go back and check out previous topics from start to finish of the processing flow within injection molding, sustainability, mechatronics, shipping, logistics, material forecasts, and so forth. So again, thank you all for joining us today. Any final comments, Mitch?
No, just, on behalf of my team, thank you so much, Nicole. You've been a great moderator, and we really appreciate everything that the Prishak family has done, Plastek Group has done for us, and the support that we've gotten from the entire community in Erie Insurance, and Penn State Barron campus, university have all been terrific. So we're incredibly excited and proud to be working with Erie on developing this program.
Thank you. We'll be cheering for breaking ground in 2023. Without further ado, we hope that everyone enjoys the rest of their day, and you will be prompted with a brief survey. We appreciate your feedback as you exit the webinar. Thank you, everyone.
Thanks, Nicole.
Thank you, Nicole.